Okay, so today we are going to look at circles in the coordinate plane and looking at their equations. So really quickly, when we talk about coordinate plane, we're talking about the x and y axis system, like coordinate system. Okay, so we've seen circles in a geometric sense. We've seen circles before in geometry, but today we're going to look at their equations and how we can use equations of circles to represent these shapes algebraically. Just like in geometry, we're going to understand our circle to be a set of points in a plane that are a fixed distance called the radius from a fixed point called the center. In the coordinate plane, the standard form equation of a circle with, and there's actually a word missing here, with center h comma k and radius r. Such a circle with center h comma k, radius r can be described by this equation here. So we have x minus h parentheses squared plus y minus k parentheses squared, where h is the x coordinate of the center and k is the y coordinate of the center. Notice that it's set equal to r squared. So please make note of that the equation of our circle is set equal to our radius squared. There's a square on every single term. It's not just the radius, it's radius squared. So we can use this format, or this kind of skeleton of an equation, to write the equations of circles given the center and radius along with other pieces of information. So we'll start with an example. This first example, it says, write the standard form equation of the circle with center 2 comma negative 1. So this piece of information, the fact that we have a center at 2 comma negative 1, gives us that h equals 2 and k equals negative 1. We're told then that our radius is equal to 3. So we can take those three components, those three pieces of information, and plug them into the equation for a circle that we saw above, where we have x minus h, so that would be 2, quantity squared, plus y minus k. Notice here that k is negative 1, so we want to be careful with that. And then that's squared set equal to radius, which is 3 squared. This simplifies to a final answer of x minus 2 squared plus y plus 1 squared equals 9. So this is the equation that I'm boxing here of a circle with center 2 comma negative 1 and radius 3. We can come up with this equation from a picture as well. Our second example has us take a picture, a sketch of a circle, and asks us to write the standard form equation of the circle. So in order to do this, you'll notice that we need a center and we need a radius or radius squared, right? From one we can deduce the other. So we'll notice that our center here is at the point 3 comma 0, where h equals 3 and k is then 0. And off of our graph we can pick out the radius, the distance from our center out to an outer edge, is 2 units. So we fill out the equation x minus h squared plus y minus k squared equals r squared, just like we did previously. We have x minus our h value of 3, y minus our k value of 0 is is equal to our radius 2, which is also squared. And this simplifies and can simplify to quantity x minus 3 squared plus y squared. Here I'm just condensing that subtraction of 0 in that second term, and then that is equal to 4. So simplifying that statement of 2 squared. So the equation that I box here is the equation of a circle that has a center of positive 3 comma 0, which we see on the graph, and radius of 2. So I'm going to ask that you pause the video and work practices 1 through 8. In practices 1 through 8, we're looking at building an equation from either a statement of the center and the radius or a diagram of the center of the radius, or identifying the center and the radius from an equation. So once you're done with 1 through 8, you're going to check your answers. There's a key posted to the week at a glance. It's also linked through Google Classroom. And then once you're done with practices 1 through 8, play the video for 2 more examples and next steps. So sometimes, hopefully you're watching this after having done practices 1 through 8. If not, pause and go back and come back here once you've completed those first 8 practices. Sometimes the center and the radius, right, these are really key components to building our equation, as our center and our radius. Sometimes we're not explicitly given those through an equation or a graph. In that case, we're going to have to rely on this equation. By the way, this is called the standard form equation, so that would be good to make note of officially. I think we did above, but just one more time, one more plug. This is the standard form equation. We can use this equation along with other given information to identify each, what I'm talking about there is the center and the radius, and then write the equation of the circle. So in this third example, we're asked to write the equation, or write the standard form equation, so filling this skeleton up here of a circle with center. So here we actually do have the center. We're given that the center is 3, -4, so we know that h is 3, k is -4, but we're not given a radius. Okay, we're not given a radius, but we are told that the circle passes through the point 6, 2. So that will likely be important information here in a moment. At this point, I can write x minus h squared plus y minus k squared equals r squared, where we have the minus the h value, so x minus 3, and y minus the -4, so that becomes a +4 in the equation. So notice we're almost there. We have our center, but in order to write out the equation, we need to fill in the h, the k, and the r value. So at this point, r is unknown. So we don't have, so we need to find or need to solve for this value. And we can do so by using the other point. So the other point that is given to us is 6, 2, and that can take the place of x and y. Plugging in x is 6, and y is 2, allows us to solve for this r squared quantity. Finding the r squared quantity allows us to complete the equation of the circle. So at this point, it's just simplifying, right? We're working through PEMDAS. 6 minus 3, is 3 quantity squared, plus 2 plus 4 is 6 quantity squared equals our radius squared. That tells us that our radius squared is equal to 9 plus 36, or that our radius squared is equal to 45. Now, it's really tempting to take the square root, and I understand why. We're mathematically trained to solve for a quantity, right, an unknown variable or value of r, but r squared is actually what we need our equation to equal. So we can stop here. We have that last piece of the puzzle. We were given our center, we were given another point that our circle goes through, and we can use that information to find r squared, to find what this equation should be set equal to. So our final answer is x minus 3 quantity squared plus y plus 4 quantity squared equals 45. This is the equation of the circle with center 3, -4 that passes through the point 6, 2. And we're able to write the equation because we have the center and we were able to figure out r squared. Another very common type of problem that we'll have to deal with is shown in example 4. we're asked to write the standard form equation of a circle with 5 comma 1 and 3 comma negative 1 as the endpoints of the diameter. So this is new information. Okay? We don't have the center anywhere, we don't have the radius anywhere, but we do have very, very important characteristic that's going to help us get to both of those. So a diameter, a couple of things we want to remember about a diameter. We know that it goes through the center. In fact, more specifically, it's a line segment that goes through the center of our circle. The center, so the center, which is something that we're going to need, is the midpoint of the diameter. Okay, so if I'm thinking about this graph, or this kind of just thinking about a picture of this situation, let's see, we have 5 comma 1 roughly here, and we have 3 comma negative 1 over here. If I have a diameter, that's going to connect these 2 points, and it's going to go through the center of the circle. Okay, it's going to have to go through the center of the circle. That's important because that tells me that the midpoint of these 2 points is the center. So that's one of the pieces of information we need to figure out. So center is equal to midpoint of the diameter. We find the midpoint between 2 points by taking the average of our x's and the average of our y's. So the midpoint formula, in case you wanted to write it down, is x1 plus x2 over 2, comma y1 plus y2 over 2. But I think it's kind of unnecessary to worry about committing that to memory. If you can just remember the midpoint is the average of our x's, comma the average of our y's. So the center is going to be 3 plus 5 divided by 2, right? We're averaging 2 numbers, so we need to divide by 2, comma negative 1 plus 1 divided by 2. That means our center is 8 comma 2 and 0 comma 2. That simplifies to the point 4 comma 0. So we have that our center is 4 comma 0. On top of that, we have information that will help us find our radius, because remember, the center is the midpoint of the diameter. That means it splits the diameter into equal pieces, and that actually helps us find the radius of whatever circle exists connecting these 2 points. Okay? So we can actually now use our center and one of these endpoints, just like we saw in the previous example, to figure out our value of r, to figure out r squared, to write our final equation. So at this point, we have x minus 4 squared plus y minus 0 squared equals r squared. As I mentioned, this is an unknown value, and our 4 and our 0 came from the center. We can figure out our r squared by utilizing one of our other x, y points. So I'm going to use 5 comma 1. Plug in 5 for x, y for 1, or 1 for y. So we have 5 minus 4 squared plus 1 minus 0 squared is equal to r squared. On the left-hand side, this cleans up to 1 squared plus 1 squared equals r squared, further simplifies to r squared equals 2. At this point, we know our center. We were able to figure that out, and we have our r squared quantity. So we can write a final answer, a final equation of our circle of x minus 4 squared plus y squared. Again, just condensing that subtraction of 2 in this term to just the statement of y squared is equal to 2. So this circle, or this equation, represents a circle not only with center 4 comma 0 and radius of square root of 2, but of a circle that has diameter endpoints of 3 comma negative 1 and 5 comma 1. At this point, I would like you to go ahead and transition into using these notes and these examples to answer questions or practices 9 through 12. Once you finish that, you'll then again check your answers to the key posted to the week at a glance, and you should start your Delta Math assignment. The Delta Math assignment is called PC, which stands for pre-calc, in case you're wondering, circle practice, and it is due Thursday, March 25th by 11:59 p.m. That will help you prepare for your check-in on Friday. As you work through either the practices, the notes, or the Delta Math, please make note of any questions you have for me so you can ask them either Tuesday, tomorrow during asynchronous time, or Wednesday during Mortal and Gold. I hope you have a wonderful rest of your Monday, and I will see you tomorrow.